All right, so I believe I'm recording here. We have two functions, f and g, and they're asking us to determine yes or no, are they inverses of each other? And they want us to determine that by finding the function composition of each one. So if f composed with g and g composed with f both equal x, then we conclude yes, they are inverse functions. If not, we conclude no, that they are not. So let's find f composed with g of x. So we're taking the function g as the input for f. And g is the function x divided by 2. Well, what does the function f always do to the input? It always creates a fraction. Negative 2 is always in the numerator, and the denominator is always the input. This denominator is x divided by 2. This is a complex fraction, and we can also write this as negative 2 and use this division symbol in place of this fraction bar. And I have found that that often jogs students' memories on how to divide fractions. We divide by changing division to multiplication, but taking the reciprocal of the divisor. We change this division to multiplication, and the reciprocal meaning that we flip this fraction. So to multiply these two together, we get negative 4 divided by x. So I can conclude right now that these are not inverses of each other. But just for practice, I'm going to go ahead and find the other composition to illustrate that it's not going to equal x either. So what does g do to the input? G always creates a fraction. The denominator is always 2, and the numerator is always the input. This time our input is a fraction, so we have a complex fraction. But just like over here, we can rewrite this as negative 2 over x divided by 2, and we can change that division to multiplication if we flip the divisor, take the reciprocal of the divisor. So here, when I multiply these together, I get negative 1 over x, and that's not equal to x. So had I done this one first, I would have concluded they are not inverses either. So technically, as soon as I get something that's not equal to x, I can stop and say, no, they're not inverses. But I didn't know at the beginning of this problem, on your homework solution, did you find f of g first, f composed with g first, or g composed with f? So this way I've covered everybody's solution. Talk to you later. Bye.